Hey everyone, welcome back to another session in this AP Calculus AB and BC course. So today we are going to start Unit 10, which is specially for the BC students only, which weighs around 17 to 18% of their paper. So if you need a regular session or one-to-one tutoring, you can book your free demo using this number. You can contact us on WhatsApp or Telegram. And if you need any other detail or have any other doubt, please feel free to connect with us in comment box also. So let's get started. Topic 10, which is infinite sequences and series, and here we will discuss what are the conditions or to find or verify a function sequence or the series is convergent or divergent. There are various tests, and under some conditions some tests also gets failed, so we have to check for that as well. Okay, so we will discuss all these things. So let's get started with the defining the convergent and divergent infinite series. Basically, if you have a sequence, let's say an is the nth term of that sequence. Okay, so if you have a sequence, then for example its terms are a1, a2, a3 and so on up to some an. What is series? Series is the sum of the terms of the sequence. So S is, or let's write it Sn. Sn represents sum of first n terms. So A1 plus A2 plus A3 plus so on up to An. It is Sn. But if you need its partial sum, or let's say you need sum of all the terms of that right sequence, so you can also do it sum of infinite terms. What is that? It is summation of Sn, where n starts from 1 to infinity. Okay. Now, if this gives you a finite answer, then we call that series as convergent. But if this is not bounded, right, it is trending towards infinity or minus infinity, then we call it divergent series. That's the definition. Same for the sequence. If the nth term, if I find limit n tending to infinity for nth term of the sequence, not the series, for the sequence, if its nth term gives you a finite number, okay, it comes out as a finite number, then we call it convergent. But if the nth term of that sequence gives infinity or negative infinity, right, or is not giving you a finite value, in that case we call it divergent sequence. So that's the meaning of convergent and divergent sequences and series. Sequence, you just have to check the last term only, and for the series you have to take the sum of all the terms of that sequence. Okay, tending towards infinity. So you are already familiar with the geometric series, right? Sum of infinite terms of a GP is given by A over 1 minus R. But the condition is R, the common ratio, must lie between -1 to +1. Then only you can find the sum of infinite terms. Otherwise, it is divergent for the geometric series. Okay. So, for example, if we have, let's say, 1 by 2, 1 by 4, 1 by 8, 1 by 16. It's a GP, right? It is a GP. And if we want to find the sum of its infinite terms, here you can see that whether the terms 0.5, 0.25, 0.125, 0.0625, and as you can see, terms are becoming smaller and smaller and smaller. If I take thousandth term of the same sequence, that will be almost 0. Okay, so I can say it's this sequence is convergent to 0. And what about series? It's a geometric series, right? So S infinity will be given by A over 1 minus R. R is what? Half again. So 1 minus this. Okay. Now let's simplify it. What do you get? 1 by 2 divided by 1 by 2 gives you 1. So this series is also convergent. Okay. So this was for geometric series only. Now let's discuss how to check whether the series is divergent or not using the nth test for the divergence. This test is very simple and easy to apply. All you have to do is just check the limit n tends to infinity n an, means the nth term, right, of that sequence. If that is not equal to 0, then the series, corresponding series is divergent. Okay. For example, take these questions. I'll solve this one first. 2, 3 by 4, 4 by 9, 5 by 16, 6 by 25 and so on. So first we need its general term. So can you see the pattern? Yes, 2 by 1, 3 by 4, 4 by 9, 5 by 16. In the denominator there is a square and in the numerator what is that? Position plus 1 if you see. For the term 1 it is 2. So for the second term it is 3. Third term numerator is 4. Fourth term numerator is 5. So nth term will have numerator n plus 1 divided by what is the denominator? It is position squared. So a this is n squared. So that is the nth term of this, right? Now I have to check whether what is the limiting value of this. Okay, so this is the general term. Now I need to find limit n tends to infinity an. If this is not equal to 0, series is divergent. Okay, if it is equal to 0, series may converge. So here an is equals to limit n tends to infinity n plus 1 by n squared. Now you know how to simplify the limiting values. Yes, either use L'Hopital's rule, you can use L'Hopital's rule here, or you can take out the highest powers common from both numerator and denominator. So if I use L'Hopital's rule, because it is giving me infinity upon infinity form, limit n tends to infinity. For the L'Hopital's rule, you have to differentiate the numerator first. So what is that? 1 plus 0. And differentiate the denominator. What is that? By 2n. So 1 by 2n, n tending to infinity. Obviously, this number is going to be 0. Right? It is approaching towards 0 because you are having 1 by n. And n tends to infinity gives you 1 by n tending to 0. So in this case, yes, we can say the series is convergent. Next one, let's talk about this one. Another term divergence test we have to apply for this. This time series itself is given. We don't need to find its general term. Okay. So simply find its limiting value. Okay. So all we have to do is solve for limit n tending to infinity for this. It is n cubed plus 3n squared plus 1 over 4n cubed minus 5n plus 2. Since it is cubic in numerator, cubic in denominator, polynomial over polynomial, limit n tends to infinity, either take highest power common and simplify it, or use the L'Hopital's rule 3 times, or since the degree are same in both numerator and denominator, its value you can directly also write highest uh, coefficient of highest power of numerator n cube have in one coefficient of highest power of denominator by 4. So 1 by 4. What is that? Is it 0? No, it is not 0. If this is not 0, then this series is divergent. That's the answer. As simple as that. So nth term divergence test is very easy to apply. Okay. So let's look at the some other tests like integral test. For the integral test, there is a condition. Your function must be positive, decreasing, and continuous function. If you have a function which is which is all positive, decreasing, as well as continuous function, then this series and starts from 1 to infinity an gives you the same result as this integration 1 to infinity for f and dl. Whether if first one converges, second converges. First one diverges, second diverges. Both behaves same. Okay. So let's look at a question first. We have 1 by n. Let's start with 1 by n only. So if we have to simplify 1 by n, where n starts from 1 to infinity, right? It is positive. Yes, it is. It is decreasing in nature because 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 keeps decreasing. It is continuous. Yes, it is continuous as well. Okay. So this will behave same as if you integrate 1 to infinity for 1 by n dn. What is the integration of 1 by n? Natural log of n. So natural log of n, but limits are 1 to infinity. Obviously n tends to infinity makes it divergent because this whole value tends towards plus infinity. So in this way, we can say this also diverges. Okay, so what we are doing actually, using the integral, right? Checking its nature. If it is divergent, then we will say our original series was also divergent. If the integral becomes convergent, then our original series is also convergent. So in this case, we got divergent. And remember this, it is harmonic series. Okay. So now our second test is P series test. What is that? A P series is a series of the form 1 by n raised to the power p, where p is a positive number. Always make sure that p must be positive number. A P series will converge if p is greater than 1, and it will diverge if p is less than equal to 1. We have already seen it for p equals to 1, right? 1 by n. We proved it that it is divergent using the integral test already. So if p is less than equal to 1, it diverges. So that you can use directly in your exam as well, P series test. Let's look at some questions. What is that? Summation of n equals to 1 to infinity, n raised to the power negative 2 by 3. So here what you can do, check for, you can apply the P test here, right? P test. It's simple to apply it. What is the power? You remember, you have to first write it 1 over np. So 1 over, it is nothing but summation n equals to 1 to infinity for 1 over n raised to the power 2/3, right? So what is p here? P is 2 by 3. 2 by 3 is 0.66 something, which is obviously less than 1. So if it is less than 1, can I say it is divergent? So divergent only. If you want, you can also use the integral test for the same question. But obviously, it is only in that 1 by n raised to the power p form. So better to use p test. Now, we have sum of n equal to 1 to infinity for the 3n over 2n squared plus 3. This time, this is our sequence, nth term. Okay, so now this is check whether it is convergent or divergent. So it's better to use uh, integral test for this question, right? It's now your choice whether you want to use integral test or you want to use nth derivative, nth term divergence test. Okay, so here I will use the integral test. So for that integral, you can simplify integration from 1 to infinity of this 3n over 2n squared plus 3 dn. Now, this and the original series will behave same, right? So let's find whether it is convergent or divergent. For that, if you want, you can write it limit a tending to infinity for integral 1 to a, right? What is that? 3n over 2n squared plus 3 dn. Now, either use u substitution, it's better to use u substitution over here. So if you use u substitution, you will get this 2n squared plus 3 equals u. That gives me 4n dn is equals to du, or we can write n dn is equals to du by 4. So simply make it 1/4 of limit a tends to infinity, right? For the integral, what is that? If lower limit, if your n is 1, what is u? n1, u is 5. If n is a, what is u? U is 2a squared plus 3. I have to change the limits as well. It gives me 3 as it is divided by u du. So simply integrate it. 3/4 of limit a tending to infinity. What is that? 3 over u, which is 3 already taken out. So natural log of u. Natural log of u limits 5 to infinity. Now you can easily see that u tends to infinity, ln u tends to infinity. So it is divergent in nature. And if it is divergent, original series also diverges because they both behave same. So this is your integral test and P series test. P series test we directly apply if we have 1 over n raised to the power p type of form, and integral test we only apply if it is a positive, decreasing and continuous function. Okay, you can remember this. IPDC, integral, positive, decreasing, continuous. Okay, next one. Comparison test. Comparison test is very useful. Okay, comparison test is used if you have a question in which you have to find whether a given series converges or diverges. Then you can create your own function, right, which you already know that it is convergent or divergent, and you can compare those two. I'll tell you. All you have to do is, if we have two series, summation an and summation bn, both are positive series, and the condition is every term of an is always less than or equal to every corresponding term of bn. Can you see this? Means a1 is less than or equal to b1, a2 is less than or equal to b2, a3 is less than or equal to b3, and so on for all terms. This must happen. Now, if I take limit n tending to infinity, look at this. That will be less than or equal to limit n tends to infinity for Bn. Now, here consider this situation. If Bn is convergent, if this is finite, if, okay, case 1. So what will happen? Obviously, An is less than or equal to that. So An is also finite. An will be finite in that case. So that is our first result. If Bn converges, then An converges. Now, second case. Let's say if this an, this value diverges, it is tending towards infinity, right? Because it's positive. That's why there is no possibility for negative. So it is tending towards infinity. And we know that Bn is always greater than or equal to that value. So this also diverges accordingly. Okay, so these are two important results. Remember this, please. Okay, so whenever Bn converges, An converges. If An diverges, Bn diverges. The thing is, what will happen if Bn diverges? If this Bn diverges, we don't know what will happen with An. No, there is no relation, no need to apply it. Or if An is given as convergent, if An is convergent, we have nothing to say about Bn. Okay, not relatable. So these are the only two results that we can use here. Bn converges, then An also converges. And if An diverges, Bn also diverges. For example, here we have this series n equals to 1 to infinity summation of e raised to the power n by n plus 3. It is not in polynomial, right? Exponential over polynomial function is there. So p series or integral, I don't want to use those. It is increasing in nature also. So the thing is, we are not able to use those previous tests, right? So what I will do, I will start with constructing a new series which we already know that it is either convergent or divergent, means we know its nature. Okay, so what I will do, I will consider a new function, I will consider a new series basically. Okay, so I'll take a new series which is summation, let's call it an, is equal to summation n equals to 1 to infinity for, take it 1 by n plus 3 simply, right? E to the power n gives you larger value. So obviously this will be, this is an, this is going to be what, less than or equal to that bnc, right, that bn part. So summation bn, what is that? That was summation n equals to 1 to infinity of e to the power n over n plus 3. Okay, now you can easily show about the nature of this one is what, 1 over n plus 3 it is. You can use your integral test this time. It's simple to integrate it, right? So integral from 1 to infinity of 1 over n plus 3 dn, and using that integral test, I'm using integral here, you can show it is divergent. So if an diverges, bn also diverges. That's the answer. So it's simple. So I used integral test as well as comparison test in this question. because I used the integral test to show that this function that I constructed in the beginning is divergent. Okay, next one. Let's consider B part. 3 to the power n over 7 to the power n plus 1. Again, I have to construct a new function. Okay, so let's take a new function. Let's say this is an this time and bn. Okay, I'll create a new function bn. Let's call it bn is equals to summation n equals to that same 1 to infinity of what? 3 by 7 raised to the n. Okay, so now our original function have plus 1 in it, means that denominator have plus 1 in it, denominator is more. If denominator is more, overall value is smaller. So I can say yes, there is a relation between these two. Now I just have to check the nature of my new function. What is that? Is it convergent or divergent? 3 by 7. 3 by 7 is a number which is less than 1. Right? 3 by 7 is a number which is less than 1. So if this number is less than 1 and if you take its power infinity, this value will tend towards 0. So simply I can say this one convergent, right? If this is convergent, our original function is also convergent. This is your comparison test. Okay? Comparison test. After this we have next test, let's call it a limit comparison test. So limit comparison test says if you have two positive series summation an and summation bn, these two positive series, such that if you divide these two and you get say finite positive number, then both the series will behave same. Again, they will give you one series in the question. You have to create second function by your own. This time why it is helpful? Because you don't need to use integral test or you don't need to check the second one, right? So here, let's first divide, construct a function, divide it, divide your original by that constructed function. If it is giving you a finite positive, then whatever be the nature of first one is, directly you can say will be the same nature for the second. I'll show you how. Consider this function. What is that? 3n plus 6 over 1 minus 5n plus 7n squared. Okay, so in this one, what we have? We have a series given by this one. So either you can use any other tests also. You can construct a new function and you can also use that comparison test. Okay, that's fine. But here I will consider my new function as, let's say, bn is equals. What is the difference between these two in the powers, terms of power? Numerator have power 1, highest power, and denominator have highest power 2. So I will construct a new function 1 by n simply. That's it. Because if I find, that is my bn. Now let's find the value of limit n tending to infinity for that an. What is that? 3n plus 6 divided by 1 minus 5n plus 7n squared, whole divided by that new what is that? Bn. What? 1 by n. 1 by n only. Now find its limiting value. You know how to calculate it, right? Take the highest powers common, or let me just first write it like this. It is limit n tending to infinity for, this is 3n squared plus 6n whole divided by 7n squared minus 5n plus 1. Highest power of n in both numerator and denominator are 2, 2, right? So this is what? 3 by 7. We don't need its value, by the way, but yes, 3 by 7 is what? Is a finite, right? Finite positive number. Finite positive number. So if you are getting a finite positive number, both converge or diverge, right? And what is the nature of 1 by n? 1 by n, use the P series, harmonic series, right? P series test. It is divergent by that. By P series, it is divergent in nature. So if it is divergent, original question also diverges. So what we are doing is actually we are constructing a new function. We are trying to find a new function. If the given function is very complicated and too many terms are there or it's weird, looking. So you can construct your own function and either use those comparison, limit comparison, integral test and all to get your answer. I hope you got all these, and we have few more topics to cover and that we will discuss in the next session. And till now, you have any doubt or have any other question, please feel free to ask your questions in the comment box. And in order to have any one-to-one tutoring or regular courses, you can connect it with us on this number using the WhatsApp or Telegram. So that's it for this session. Thank you for watching this. Keep watching, keep learning.